Okay, here's another form of your review session. So we're going to start out talking about finding critical values for different confidence levels, and this is for either a Z distribution or a T distribution. So the Z is the one that you use with proportions. So for these four on this page, these would all be using the inverse norm function on your calculator. So the first thing that you need to do is find the alpha. The alpha is 100% minus your confidence level. So the alpha for this one is going to be 10%. You want to change that to a decimal value, so you change it to 0.10. Then you find alpha over 2. So divide that by 2, which would give you 0.05. Then you're going to use the inverse norm function on your calculator. Put in the alpha over 2 that you just found. And since this is Z, that means that your mean is 0, your standard deviation is 1. So if you do this on your calculator, you're going to get something like this. Then all you do is take off the negative. So your actual critical value is just the positive value. So for this one, it would be positive 1.645. Now this is something that if you're getting ready to take your test, the Z's for the critical values are always going to be the same if you have the same confidence level. So you could go ahead and write this down. This is going to be your Z alpha over 2 for 90% confidence is always going to equal 1.645. You can do the same thing for these two, since these are a couple of other typical ones that you would normally find. So for this one, your alpha would be 0.05. Your alpha over 2 is 0.025. So if you find the critical value for that one, that's going to give you negative 1.96. So that means the Z for 95% confidence is always 1.96. You can do the same thing to find the Z for this one. Now this is one more like you might get on a test because it's asking you for a little bit different confidence level, so it might be one that you've never found before. But you just go through the same process. Find the alpha over 2, and then put it into your inverse norm on your calculator. Okay, now let's look at the ones for the T. So this, instead of using the inverse norm, these ones are going to use the inverse T on your calculator. Otherwise, you start out the same way. So you'd find your alpha. For this, it would be 10%, which is 0.10. And then alpha over 2 is going to be half of that, so it's 0.05. Then on your calculator, you use the inverse T function, and you put in 0.05, and then you have to put in the degrees of freedom. So if you have your sample size, which is your n, your degrees of freedom is n minus 1. So for this one, your degrees of freedom is 37 minus 1, which is 36. So that's what you would put into your calculator. I'll even show you how I'm doing this on my calculator. So I'm in my distribution menu, I'm using number 4, which says inverse T, and I'm putting in 0.05 and 36. Okay, so I got negative 1.69 approximately. So that means that our critical value for this is 1.69. Now for these ones with the T, since they depend on the sample size, you can't depend on getting this answer for everyone. If you had a different sample size, you'd get a different critical value. So it's only for the Z ones that you can count on it always being the same for the same confidence level. That doesn't work for the t's. You just have to calculate them every time. Okay, so here's one. This one's actually a really easy problem, but it looks like it isn't, so it confuses people a lot of times. In this one, they're already giving you the confidence interval. So they're saying this is for a proportion or a percentage. So they're saying the confidence interval is from 63% to 69%. And then they're asking you to find the point estimate and the margin of error. So what they're saying is that your confidence interval goes from 63 to 69%. The point estimate is going to be exactly halfway between these two. So you want to know the number that's exactly halfway between these two, and to get that you can always just find the average of the two numbers. So just add them together and divide by 2, and for this one that's going to give you 66. So your point estimate is going to be 66%. Then for your margin of error, that's just half the length of the confidence interval. So if you already know your point estimate, your margin of error is just how far it is from your point estimate to one of your limits for your confidence interval. So we could take the upper limit, 69%, and subtract our point estimate, and that would give us our margin of error, which would be 3% for this. Okay, in this one we're actually trying to find a confidence interval, so we would want to go through all the steps. And for this test, I would really recommend that you have your notes already pulled up on your computer before you start the test. So the notes for inferences for proportions and inferences for means, I would have those pulled up so that you have all the formulas there and you don't have to spend a lot of time looking for them. So we had the notes for inferences about proportions and the inferences about means. And another thing about having the notes is that they also have examples in them. So if you kind of get stuck on one of the test problems, you can look at some of those examples and hopefully figure it out. Okay, so for this one, first of all, you have to figure out which one of these two things we're talking about. Because this is talking about the population proportion, that means that we're looking at something to do with a proportion. And we're trying to find a confidence interval. So you would want to look up your formula for confidence intervals for proportions. And for that formula, you have the margin of error, which is this. And then for your confidence interval, you would take your point estimate, which is your p hat, plus or minus your margin of error. So the first thing in this one, you'd want to figure out your critical value. This one is a 90% confidence interval. We actually already figured out the critical value for a 90% confidence interval earlier. So we already figured that one out. That was the 1.645. And again, since this is a z, this is always going to be the same. It doesn't matter what the sample size is. So we have that number already. Then for our p hat, sometimes they'll give you the percentage or the proportion for the p hat. In this one, they didn't. What they gave you was the x, the number of successes, and they gave you the n. So to find the p hat for this one, you have to take x and divide by n. That would be 297 over 400. And if you calculate that out, it turns out to be 0.7425. So we're going to plug all of those things into this formula. So we have our 1.645. We have our p hat. And 1 minus p hat. And then our n is 400. So we're just going to plug all of that into the calculator and get our margin of error. And I usually just put this all in my calculator in one step. That way I don't have to worry about trying to round things or anything. Okay, so I got my margin of error. If I round this to 3 decimal places, I get 0.036. Okay, now to do my confidence interval limits, I'm going to take my p-hat, which was the 0.7425. So for my CI, I'm going to take 0.7425 plus or minus my margin of error. So to get my lower limit, I'm going to take my p-hat minus my margin of error, which would give me 0.7065. And to get my upper limit, I take the 0.7425 plus the margin of error. So there's my lower limit and my upper limit. So there's my confidence interval. Okay, here's a different problem kind of using the same setup, but this one is asking to find a minimum sample size. So if they're going to do another study and they want to know how big a sample they have to get a margin of error of 3% and a confidence level of 90%. So what you're asking for in this one is to find the n. Okay, so for this, again, since we're talking about proportions, there were 2 different formulas depending on whether you knew an estimate for the p-hat or whether you didn't. If this one, we actually have an estimate for the p-hat, we're going to use the one from the last problem. So if we have an estimate for p-hat, then our formula looks like this. And I'm using a little p star to stand for the estimate. So it's the p star and then 1 minus p star all over e squared. And e stands for the margin of error. Okay, so 90%, our critical value that goes in here is again that 1.645. Oops, and that's supposed to be squared. The p-hat that we're using is the p-hat from the last problem, which was 0.7425. And then we have 1 minus 0.7425. Okay, and then for the margin of error, you have to be really careful with this. If you're talking about proportions, if they give you the margin of error as a percentage, this is saying E is 3%, you have to change this to a decimal. So here we'd have 0.03 squared. Now if you have one of these where it's talking about a mean, then you just use whatever margin of error it is. You don't change those to decimals. It's only if they give it to you as a percentage that you need to change it to a decimal for this formula. Okay, and then when you put that in your calculator, once you get your answer, then you need to round it up to the next whole number. So I'm just putting all that in there and I get 574.9. So I'm going to round that up. So my minimum sample size is going to be 575. Okay, here's another one from the same thing. This one's talking about a hypothesis test. So this one is a lot more involved. First of all, we want to know what the claim is so that we know what our null and alternative hypotheses are going to be. And on the test, most of the questions like this will not have you do the entire hypothesis test in the question. They'll just have you do a piece of it. So it might ask you for the hypotheses, or it might ask you to find the test statistic. It might give you the test statistic and ask you to find the p-value. or it might give you the p-value and ask you to find the conclusion, something like that. So we'll just go through all the parts on this one. So first of all, here's our claim. Union support for the Republican candidate is over 70%. Since this is talking about a percentage, that means that this has to do with a proportion. So the parameter that we're talking about is P for proportion. Then since this says over, that means greater than. And 70%, we're going to change this to a decimal, so we're going to make it 0.70. So there's our alternative hypothesis. Then our null hypothesis, we just replace the inequality with an equal sign. So there are our hypotheses. We already know our alpha is supposed to be 0.05. And then we come to the test statistic. So this is where you want to have your notes pulled up and make sure that you're looking at the correct notes for this. This is talking about a proportion, so you should be looking for the formula for the test statistic for a proportion. Okay, so here I'm looking at my notes and going through until I get to the hypothesis tests, until I find where it has the formula for the test statistic. Okay, there it is. So my formula for my test statistic looks like this. And it's important that this is a z, because when you get to later to finding your p-value, you need to know which distribution function to use. So it's important to write down either the z or the t from this formula, besides just the rest of the formula. Okay, and the p-zeros in here, those come from your hypotheses. So this 0.70 over here is your p0. So this 0.70 over here is your p0. The p hat comes from your sample data. So that would be, again, the 297 over 400. So we're going to plug all of those things in here. Notice that the p hat only goes into here once. The p0 shows up 3 times. Oops. And you also have to put the n in there. Okay, so then we would just calculate this out. So this is going to give us 0.0425 on the top. And 0.0229 on the bottom. And then if we divide those, we get 1.86 if we round it to 2 decimal places. So this is our test statistic. This is our Z0, is the 1.86. Okay, then let's say that they give us the test statistic and we're supposed to find the p-value. So if we're doing that, the p-value is a probability. And that's where it's important what we're talking about here. The z stands for the standard normal distribution. So what we're going to do is draw the picture, put our test statistic on there. So 0's in the middle. Our test statistic would be here. And then to figure out which way this is going, we go back and look at our hypothesis. Since this is pointing to the right, that makes this a right-tailed test. And that means we're going from our test statistic to the right. So we're trying to find this probability. In your calculator, you'd use normal CDF. The 1.86 would be your lower bound. Then we'd have an upper bound, which would be a big positive number like 1,000. And since this was Z, our mean is 0 and our standard deviation is 1. So you would just put that all into your calculator. And usually for p-values, they want you to round it to 4 decimal places. So this would be our p-value. Okay, then if you have the p-value and you're trying to find the conclusion for the test, this is where you compare the p-value and the alpha. So here's our p-value. Our alpha up here was 0.05. What you want to know is whether the p-value is less than or equal to alpha or not. So you take your p-value and put it on this side, take your alpha and put it on this side, and we want to know whether this is true or false. Since 0.03 is smaller than 0.05, this is true. What that means is that we have positive conclusions for our test. So we'd have, we would want to say that we do reject the null hypothesis, and we'd say there is sufficient evidence to support our claim. So our original claim was that the union's support for the Republican candidate is over 70%, so we do have sufficient evidence to support that. Okay, so all the ones we've done so far have had to do with proportions. Here's one that has to do with a mean instead. So in this one, the way you could tell it has to do with a mean is that it's talking about a sample mean. It gives you a sample standard deviation, and then it's asking for a 95% confidence interval for a mean. So this means that you'd want to look at your notes for means and find the right formulas. Okay, so if we're doing a confidence interval, here's our formula for the margin of error. So we're going to have E equals T alpha over 2 times S over the square root of N. Okay, so the T right here tells you that to find your critical value, you need to use the inverse T. So that means you also need to know your sample size so that you can have your degrees of freedom. The S is the standard deviation, so it should have given you a standard deviation. The N is the sample size. Okay, so to find our T alpha over 2, we have 95% confidence, so that means our alpha is 5%, which is 0.05. Alpha over 2 is 0.025. So on our calculator, we're going to use inverse T with 0.025, and then our degrees of freedom is going to be N minus 1. And our N, since we had 41 chicken eggs, that's our N. So our N minus 1 would be 40. So you would just do that on your calculator. On your calculator, it's going to give you negative 2.02. We're just going to take off the negative for our formula. So for our formula, we have 2.02. Our S was 15.4. Our N was 41. So we put those three things into the formula. And we would get 4.9. So there's our margin of error is 4.9. So now to do our confidence interval, we're going to take our point estimate. In this one, our point estimate is our sample mean. So we take our x bar plus or minus our margin of error. So that's going to be 193 plus or minus 4.9. So we'd subtract the 4.9 to get the lower limit. So we'd get 188.1, and we'd add the 4.9 to get our upper limit, which would be 197.9. So there's our confidence interval. Okay, so this one is kind of based on the same problem, only here it's asking you to test a claim. So it's asking you to do a hypothesis test. And again, you might have to do different pieces of something like this. So the first piece would be figuring out the null and alternative hypotheses. So if you just look at the claim part, our claim is that the average cholesterol content is different than 213 milligrams. Average is another word for mean. So if you were just trying to do this problem from scratch, as soon as you see the word average, that means that it has something to do with means. Okay, so that means our parameter that we're using is mu. And here, the only word that it uses is different. It doesn't have anything about more or less. So that means we're going to use a not equal to, and 213 is our number. So then for our null hypothesis, it would be mu is equal to 213. Okay, then for our test statistic, we'd want to go back to our notes and go down to hypothesis tests for means and find where it has the test statistic formula. So here it is right here. So, and this one, again, you want to write down the letter as well as the rest of the formula. So this is x bar minus mu 0 over s over the square root of n. Okay, so here's our test statistic formula. Again, anything with a 0 subscript comes from your hypothesis. So our 213 is our mu 0. All these other three numbers come from our sample data. So the x bar is the sample mean. Our sample mean was 193. The s is the sample standard deviation, so that's the 15.4. And then the n is the sample size, so that's 41. And on this, if you're trying to put it all in your calculator in one step, you need to use lots of parentheses. You even need to put parentheses around this part on the bottom. If you do it that way, you'll get the correct answer. Okay, so this turns out to be negative 8.32. So that would be our test statistic. Now, if you had this for a test statistic and you're trying to find the p-value, this is kind of a hard one because since this was a not equal to, this is actually a two-tailed test. So we're going to find our probability, and then since we have a two-tailed test, we have to multiply it by 2. So what we're going to do is draw a little picture. We're going to put our test statistic on here. So here's our test statistic way over here. Since this is to the left of 0, that means we're going to look in the left tail of our distribution. So if it were positive, we'd be looking at the right tail. Since it's negative, we're looking at the left tail. So in this, because this was a t, that means we're doing the t-CDF. So our lower bound is going to be a big negative number like negative 1,000. Our test statistic is going to be our upper bound. And then here we put in the degrees of freedom. Since our sample size was 41, our degrees of freedom is 40. And this is going to come out to be an extremely small number. So what I'm getting on my calculator looks like this. The E means it's doing it in scientific notation because it's such a small number. This would be the same as this number times 10 to the negative 10th. That's what that E means on your calculator. Okay, so this was just for the left tail. Because this was a two-tailed test, we want to take this and multiply it by 2. So all I'm going to do on my calculator is where I have this answer in here, I'm just going to do times 2, and then I don't have to try to put that number back in there. So for my p-value, I get 2.96268 times 10 to the negative 10th. So that would be like a decimal point and then 9 zeros and then this number. So it's extremely small. Okay, then you're also going to have a few that have to do with two populations. We talked about comparing means when we have two populations. And there are two possibilities. You can have independent samples or dependent samples. So in these ones, it's just asking you to write the null and alternative hypotheses. And really before you do that, you have to figure out whether you have independent or dependent samples. So in this one, the key is that you've got the subjects in the study and they were measured before and after the hypnosis. So in other words, for each subject, you have two measurements. So if we had Joe and his before measurement and his after measurement, and maybe you have me and you have my before measurement and my after measurement. So for each person you have a pair of measurements. That means if you have two things that are related, then you have dependent samples. So what that means is that if you're trying to do a hypothesis for this, your parameter, you're not going to have two different means in your parameter, you just have one. So this is the mean of the differences. So for each person in the study, they would be figuring out the difference between their pain measurements. So like this guy would be 3, for mine it would be a 6, would be the difference. So you're just going to do everything with the differences. And what you would want to know for your hypothesis is, should these differences be coming out to be positive numbers or negative numbers? So in other words, on the average, were the before measurements bigger or smaller than the after measurements? And on this one, if the hypnosis was working, then you'd expect the after measurements to be smaller. So that means that your differences should mostly come out to be positive. So your H1 would be that U sub D is greater than 0. Your null hypothesis would be that it's equal to 0. Okay, let's look at another one. Okay, so this one, we also had two populations, two samples. So this one, our two samples, we've got brain volumes for afflicted patients. So that's one sample, and then brain volumes for healthy patients. If you read through the rest of this, it doesn't say anything about the afflicted patients and the healthy patients being related to each other in any way. So this one is going to be independent samples. The other way that you can tell is that it talks about the averages, and it says the word average twice. Average is the same as mean. So it's talking about the average for the afflicted patients, and then the average for the healthy patients. That means basically you have a mu1 and a mu2. So for your H1, you're going to have mu1 and mu2, and you want to know whether one is bigger than the other one, or whether they're just not equal to each other. So this one in the claim, it doesn't say anything about more or less, it just says whether they're different. So all you can say here is mu1 is not equal to mu2. Then for your null hypothesis, it would be that mu1 is equal to mu2. Okay, here's another one. So on this one we have 40 collision claims from 20 to 24-year-old drivers, and then another 40 collision claims from 30 to 59-year-old drivers. Again, in this one, it doesn't say anything about any kind of relationship between the drivers. We just had one random sample of 40 claims and another completely independent random sample of another 40 claims. So this one is also independent samples. Okay, and then also on this one you can kind of look at what the claim says. So it says the average claim for 20 to 24-year-old drivers is higher than that for 30 to 50-year-old drivers. So one average is higher than another. That means you're talking about two different means. So your alternative hypothesis, if you're taking the 20 to 24-year-olds as your first population, the mean for them would be the mu1. You're testing whether that's higher than the mean for the 30 to 50-year-old drivers. So this would be your alternative hypothesis. Your null hypothesis would just be where these two are equal. Okay, and for something like this, if they're actually having you figure out a test statistic or something, they have to give you the sample data for the two different samples. So in this, the information from the first sample, from the 24 to 24-year-old drivers, the N is 40 because they looked at 40 claims. The X1 bar is the sample mean, so that's the 4540. The S1 is the sample standard deviation, so that's the 2291. So this is all from your first sample. From your second sample, we also had 40 claims, so that is 40. The mean was 3660, and the standard deviation was 2036. So on this, if they're wanting you to do something with this, they have to give you those sample statistics for the two different samples separately. So then on something like this, you could either be doing something with a confidence interval, or you could be doing something with a hypothesis test. Either way, you definitely need to have the formulas to deal with those. So the formulas for these, here's the test statistic if you're trying to do a hypothesis test, or if you're trying to do a confidence interval, here's the formula for the confidence interval for the margin of error. So again, just be sure and have all those pulled up so that you don't have to look for them very hard. And like in this one, there's an example of finding the confidence interval. So you could even kind of follow through the example to do a problem on the test. And this has some other stuff about the dependent versus independent samples to help you with that.